Now that we have document or matrix created in order to organize the data, which contains these comedian name in the rows, and here at the column we can see the word that has been spoken by all of these comedians. And if the word has been spoken by that comedian, then the value for it will be 1. If it is not, the value for that word will be 0. And that is how we organize our data, the textual data. Now let us do something called as exploratory data analysis. After that data has been cleaned, what we did in the previous step, we put our data into the few standard format. So we did something called as a document or matrix as a format to store the data. Now the next step is to take a look at the data and see if what we are looking at makes sense. So basically we are going to analyze our data and make sure that this data make sense. Before applying any fancy algorithms, it is always important to explore the data first. When working with the numerical data, some of the exploratory data analysis technique, we can also include finding the average of a data set, or maybe checking the distribution of the data, or checking the most common values on the data. So that is for the numerical data. But in the natural language processing, we no longer have the numerical data. We have the text data, something like this, text. See here the word, the sentence. We have the textual data. So in the case of textual data, we are going to find some more obvious pattern with EDA, with exploratory data analysis, or simply EDA, before identifying the hidden patterns with machine learning technique. So we are going to look at the following things for each comedian, like what are the most common word that each of these comedian speaks, like creating the word cloud for it. And similarly we can check the size of a vocabulary, like look at the number of unique words each of these comedian have spoken, and amount of profanity, like most common terms, which is the bad word. So how many bad word have each of these comedian have spoken. So this can be a exploratory data analysis that you can normally do with the textual data. So we are going to just use these 3 techniques. Like the first one, we will check what are the most common word, then the size of vocabulary, then the amount of profanity. So for that, let us start with the first one, and I'll just give the name here, that is amount, that is first we'll do most common word that is spoken by each of these comedians. So now first of all, our data format, if you have seen, would be right here, which is our data underscore DTM. So this is the final output what we have achieved in the previous video. So that is a document or matrix. Now here I'm going to find the top, let's say 30 words. I want to find the top 30 words said or spoken by each comedians. So for that I'm going to make a dictionary. In the case of natural language processing, rather than using list and tuple, using the dictionary makes more sense. And for C in data dot columns, so data dot columns, but before that I think what I need to do is, maybe it is the data dot DTM. If I print here, you can see these are my rows. So here Ali, Anthony, Bill, so these are the index in fact. So I can just transpose our data. First of all, data dot DTM dot transpose, and I can store it onto our data variable. Now if I print data variable for you, then you will see that it has been transposed. So transposition means the row will become column and column will become row. Now see here, so initially our that is comedian name was right here. Now we transpose it so that these things like our comedian name will go at the column side and these words will be over here. So that is a transposition. See here, it has been transposed now. So at the top you can see the comedian name, and at the index side we can see the words. So initially if you see, our dimension was 12 rows and 7 3 4 5 columns. Now after you transpose, they will interchange, like the columns will be 12 and the row will become 7 3 4 5. So their value will be interchanged. See here, now their value has been interchanged. So that is what transpose does. Now after we make the transpose of our document of matrix that we have created previously, now we can find the top 30 word that has been spoken by each of these comedians. So for that I loop around these comedians first. So data dot columns now is this columns, like first of all we'll get Ali, then Anthony, then Bill, and so on. From here I'm going to create a top variable and I'll just get data C. Since this is a dictionary, if you remember, this would be dictionary, and in that dictionary I'll get the comedian value and I'll sort the values in ascending order or maybe in the descending order. So ascending value will give false, and I want 10, like that is 10 words, maybe 10 words for each comedian. Now I need to zip it to my top dictionary, so I want to store it right here. After I find each of that word spoken by the comedian, I will store it with the name or with the key as a comedian. And here what I can do is, in our case there will be two things. The first one will be index and next will be values. So from this top, if you see in this top, what we will have is, I can also print the top for you, print top, and if I run it, then you can see this is the top. So this is the top for Ricky. So this is the top for Ricky. If I just print inside it, then if I print it, then you can see the top word for each of the, that is our comedians. So at first you can see this is the top 10 words, because we have given this 10 here. So these are the top 10 words spoken by Ali, these are the top 10 words spoken by Anthony, and so on. We have for all of them, we have right here. So here you can see in this top we have first this index. So index are nothing but the word, and on this top we have these values. So values are the count. So how many times the comedian Ali has spoken the word like. So he has spoken 126 times. So we can extract that now. So top dect and give the comedian as a key, and I will pass here top dot index and top dot values. So top dot index is this word and top dot values is this count, and I can zip them together and I can create the list for each of these comedians and store it into the list, the word as well as their, that is the count. Now this looks fine. Let us print now top dect, that is for the dictionary. It is where we have stored right here. So after we print it, then you can see Ali was the key which we got from here. The first was the Ali, and then we can see in the list we have got this much values, or like 10 top words, where the first one is the word. From here top dot index has this value and top dot values will be the count of the word, the top word count that is done by Ali. And similarly we have for the next comedian, because we are creating a loop. So at the first time the loop for Ali will be called, at second iteration the loop for Anthony will be called, and so on. And we are sorting the value in ascending order, or basically in the descending order. So that was the reason we can see this is our top word that has been spoken by each of these comedians. And it is quite hard to just see here, it is really hard to check all these words. So what I can do is I can refine this dictionary. So this dictionary contains these things, so I can refine that, so that if you want to view it, it will be in a proper order. So I'll say print the top 15 words, let's say, spoken by each comedians. So I'll loop around comedian and top words in top dict dot items. So top dict is our dictionary, and if you call the item function onto our dictionary, this dictionary will be converted into tuples, and in the tuples we can loop. So the comedian will be key, and the top word will be all these values till here for the case of Ali. And for the case of Anthony, the key will be Anthony, and all of his word will be right here, and so on. So we will loop around each of those words, and I will print the comedian name first, then after we can print the word. So here I'm going to give the join function to work around with each of the word. So I'll just call join. So join here basically does is like, we will print like first, and comma and no, and comma and just. So basically we are printing only the word now. And here inside the join, what we need to do is we need to pass the word. So I can use the list comprehension, word in, or word for word, and count in top words, and we need 14 top words for each of the comedians. So that means 15 top word in fact. So I have sliced it right here. So basically what this line of code does is, we are going to loop around each of these words by this for loop. So we are going to use this for loop to loop around each of the top words, and after we get each of the top words, we are going to print the word only. Here we are not using the count, we don't want count. So count is these values, we don't want count, we only want to extract the word. So that is the reason we print the word, and we join each of these word with the commas, and that is how we do it. And let us differentiate one comedian with another by this, that is some differentiation. Let us print, and let me show you what I mean. See here, so first the comedian name was printed by this command, and next we can see all the word has been printed by having the comma in between them. So comma is right here, and within the comma you can see we joined each of the word, and then after we print this in order to differentiate one comedian with another. So this is all the top words that has been spoken by each of these comedians. You can do the analysis right here. If you want to change the values from the top word from 10 to some other word, let's say if you want top 30 word, so instead of 10, if you want top 30 word, then you can do it. Now we have top 30 word that has been spoken, and now if you want top 15 word, then you can see these are the word. So you can just refine here in the top word, because whenever we extract the top word we use 30 here. So 30 top words has been extracted and it was inserted inside the dictionary. So from top 30 word we extracted the top 15 word again. So for each of these comedian we extracted them and we printed right here. So in this way you can see what are the top word that has been spoken by each of these comedians. Now, let us do another things like we can create a word cloud for it, and it is an important thing. So